So we're going to move on to multiplying rational expressions, and really they're barely different than just simplifying rational expressions. Remember, a rational expression is just a fraction, so we do want to make sure we remember how to multiply fractions. So this basic one, you just are multiplying numerator and denominator and denominator. So you're just going straight across, and we would get 18 over 24, and then of course we'd have to reduce that. And the biggest number that goes into both of those would be 6. So you divide 18 by 6 and get 3, and 24 by 6 and get 4. And that's basically all we're going to do again. But I do want to point out that you can kind of do this a little bit quicker. You can actually do your reducing earlier in the problem, because when you're multiplying this problem, it's really just 2 times 9 over 3 times 8. And so you could say, if you want to think about it long ways, you could say, well, it's 2 times 3 times 3, and 3 times 2 times 2 times 2. And then you're just canceling the 2's and then the 3's, and you're left with 3 over 2 times 2, which is 4. And even a further way to think about that would be to say, well, I can divide the numerator by 2 and the denominator by 2, and we'll be left with a 4 there, and divide this denominator by 3 and this one by 3 and be left with a 3 there, and be at 3/4 that way also. So, since we're just doing multiplication, it's almost exactly the same as just simplifying in general. So here's another multiplying example with a little bit more complexity to it. And I'm going to kind of just write it out by kind of just shoving everything together. And so what I mean by that is I am going to do, we are multiplying, but if we multiply the numerator here, then we're going to get 2 times 5, and really it doesn't matter what that is. And then x, we'll have 3 x's up there now, and 2 y's. And in the denominator, we'll have a 3 with 3 x's and 3 y's. And so all we're doing now is just simplifying like we did before. So 2 and 5 and 3, none of those cancel, but we can cancel 3 x's down here and 3 x's up here. The numerator, we can cancel 2 y's, and then the denominator, another 2 y's. And so this just gets straight to 10 over 3y. So the point is that multiplying these numbers together is fine. I mean, you could go straight to 10x cubed, right? I mean, if you wanted to instead, you could say, well, okay, so the numerator is 10x cubed y squared over 3x cubed y cubed, and then just simplify it from there. Or you can simplify, there's no real need, I guess is what I'm trying to say. There's real no need to get this to a 10. You're just looking for things to cancel anyway. So, the answer is 10 over 3y. So the steps that you want to think about when you're doing these is, we still need things factored before we can simplify them. And so the order that you want to go through this is exactly the same as when you were just simplifying rational expressions. So you want to factor everything completely as far as you can. That includes the greatest common factor, includes a times c, includes difference of squares, etc. And then what I want you to do is just take the two fractions that you have and just shove the numerators together and shove the denominators together. If you have a bunch of factors in the numerators, if you're multiplying two numerators that are a bunch of factors together, then you just have a bunch of factors. And the same with the denominator. And then all you got to do is look for common factors and cancel. So again, this is barely any different than what you were just looking at doing simplifying rational expressions. So here's an example, and we do want to factor everything we can. So in the first numerator, we can take out a 2, and we're left with x plus 1. Nothing really going on in the denominator, and nothing really going on in the numerator on the second one. But we can take a 4 out of the denominator of the second expression, and we're left with x plus 1. And again, there's a lot of ways that you can think about this, but I think it's easiest just to say, well, this is really 2 times 9x times x plus 1, and the denominator is really 3 times 4 times x plus 1. And then you're just looking for things to cancel. Now, I didn't expand it out all the way, but you can really say that 9 is 3 times 3, and 4 is 2 times 2. So then when you're looking to cancel things, you can say, well, here's a 3 that I can cancel, here's a 2 that I can cancel, and here's an x plus 1 that I can cancel. And so what you're left with then is a 3x in the numerator and a 2 in the denominator. So I'm going to start off by just factoring everything that I can, and if you notice that the first rational expression there is just difference of squares on both numerator and denominator, then you can easily get to x plus 8 and x minus 8 in the first numerator, and x plus 3 and x minus 3 in the first denominator. And then we're just going to shove everything together. So the numerator is going to be x plus 8, x minus 8, and x plus 3. And the denominator is going to be x plus 3, x minus 3, and x plus 8. Again, we're just multiplying factors together. So now you're looking for things to cancel, and we have an x plus 8 that can be canceled, and an x plus 3 that can be canceled, and there's nothing else that we can do. So our final answer is going to be x minus 8 over x minus 3. Okay, so the first step should be factoring everything you can. You're going to have to use the a times c method on at least the first numerator. 1 times negative 35 is negative 35. Factors of negative 35 that I had to give you negative 2 are 5 and negative 7. Thank you. And the greatest common factor of the denominator there is x squared, so we're going to take that out. And we're left with 2x minus 3. Moving on to the second rational expression. We're going to take an x out first, and we'd be left with x and then 4x squared minus 9. 4x squared minus 9 is the difference of squares, so that numerator is going to be x times 2x plus 3, 2x minus 3. And then we'll take a 7 out of the denominator and be left with x minus 7. And again, since we're multiplying, we can just shove everything together. And the numerator is going to be x, 2x plus 3, 2x minus 3, x plus 5, x minus 7, all over x squared, 7x squared, 2x minus 3, and x minus 7. And then all we're doing is looking for common factors. So the 2x minus 3's are canceled, the x minus 7's are also canceled, and one of the x's is going to be canceled. So our final answer is going to look like this. X plus 5, 2x plus 3, over 7x, just 7x. All right, and that's as simplified as you can get.